Welcome to Training Module 8 on Electrical Grid Testing and Commissioning. Today, we're focusing on the Static VAR Compensation System, a key technology used to improve voltage stability and power quality in the grid. This module is designed to equip you with the essential knowledge and practical skills needed for effective testing and commissioning of these systems. Let's dive in and explore how static VAR compensation enhances grid performance. On this slide, we outline the key reference frameworks that guide testing and commissioning of electrical grids. You'll see several important organizations listed here, such as the IEC, which stands for the International Electrotechnical Commission, and the IEEE, or Institute of Electrical and Electronics Engineers. These bodies develop global standards that ensure safety and reliability. Other significant references include ASTM, known for Materials Testing Standards, and NEMA, which represents electrical manufacturers. We also have ANSI, the American National Standards Institute, and SIGER, the International Council on Large Electric Systems, which focuses on large-scale electrical systems. Additionally, ICA provides standards for insulated cables, and KEMA serves as a verification body for electrical engineering materials. A crucial governance rule to remember is that when project specs, manufacturer instructions, and standards differ, you must apply the most stringent approved requirement. Plus, always document the reference used on your test sheets. This way, anyone reviewing the tests later can understand exactly why a result was accepted. Here we have an overview of the Static VAR Compensation Commissioning Schematic, Part 1, focusing primarily on testing and commissioning the electrical grid. This section outlines the essential steps for prerequisite checks, including measuring the SVC capacitor bank neutral-unbalance and verifying voltage deviations in the RC snubber circuit. These checks are critical to ensure the system operates safely and efficiently before full deployment. This information is detailed in Commissioning Manual Number 8 to 1.1, serving as a key reference throughout this process. Let's review the key steps for the Static VAR Compensation Commissioning Test, Part 1. First, we start by reviewing all approved switching orders and permits, including the lockout-tagout boundary, single-line diagrams, and control drawings to ensure everything is clear and ready. Next, we secure the work area with barricades, verify proper personal protective equipment, safely discharge any stored energy, and install temporary grounds before performing any low-voltage injection. We then confirm that all prerequisite tests for components like CT/VTs, panels, battery chargers, circuit breakers, transformers, capacitor banks, and more have been completed and accepted. After that, we isolate the test sources from the service power, identify the phase sequence, and connect the three-phase 380-volt supply precisely as shown in the schematic. For wye-connected capacitor banks, we measure the neutral unbalance current in each phase and record those readings, ensuring that the balance is 0 or within the approved tolerance. We also apply a single-phase 240-volt supply across each RC snubber group, measuring and recording the voltage there. The next step involves calculating the percentage voltage deviation for the RC snubbers using the formula based on injected voltage divided by the number of positions. Finally, we remove all test sources, safely discharge and ground the system, restore the normal connections, and document everything thoroughly with photographs, test forms, calibration certificates, and witness signatures. The acceptance criteria are straightforward. All prerequisite test records must be accepted, neutral unbalance measurements should be 0 or within tolerance, and RC snubber voltage deviations must comply with project or OEM guidelines. Additionally, no abnormal heating, loose connections, wiring errors, alarms, or unresolved punch items should remain open. This leads us to the hold point where the client or commissioning witness must confirm the completion and acceptance of all prerequisite tests and measurements before we proceed to further system component tests. This meticulous process ensures both safety and reliability throughout the commissioning. Here we have the second part of the Static VAR Compensation Cooling System Schematic. This section focuses on the testing and commissioning of the electrical grid, specifically related to the cooling system components. The key areas covered include the reference schematic for the cooling water control panel and cooling fan control panel. Additionally, it's important to perform insulation resistance tests, as well as checks on starting and running currents. We also need to verify phase loss and rotation to ensure everything operates smoothly. All these procedures are detailed in Commissioning Manual number 8 to 1.2, which serves as our guide throughout this process. On this slide, we focus on the testing and commissioning of the electrical grid specifically for the Static VAR Compensator cooling system, covering motor fan and pump verification. The key tasks include verifying motor insulation, checking starting and running currents, testing phase loss response, confirming rotation direction, and completing final test form documentation. We start by confirming that all prerequisite tests from Part 1 are accepted and that the cooling panels are safe for controlled testing. Next, we verify all control panel tags, feeder supplies, terminal blocks, and interlock settings to ensure everything is correctly configured. Insulation resistance testing is performed through the terminal blocks for both motor pumps and fans, recording phase-to-phase and phase-to-ground resistance values. Following this, each cooling motor fan and pump is energized in a controlled manner to measure their starting currents across the 3 phases. After stabilization, running currents are recorded and compared against nameplate and baseline values to ensure balance and proper operation. We then calculate the total current consumption for each group, summing up individual phase measurements. Where allowed, a phase is deliberately removed to verify current behavior, protection system response, alarms, event logging, and safe reset functions. Finally, we check the rotation direction and various panel statuses, alarms, and reset procedures, documenting all findings in approved test forms before restoring normal configuration. The acceptance criteria require that insulation resistance meets standards, currents are balanced and within limits, and all alarms and protections operate correctly with no unresolved issues. The evidence package includes detailed IR test sheets, current logs, phase loss test records, rotation check reports, panel screenshots, calibration certificates, and punch closure documentation. At the hold point, commissioning witnesses confirm that the test results are satisfactory and the SVC cooling system is ready for final functional verification and energization. This thorough process ensures reliable and safe operation of the cooling system components.